All right, thank you so much. Thank you for the introduction. We are Nora and Kenneth here to talk about API security today, or more specifically, security at high speeds, how Vipps secures their APIs or our APIs. And even more specifically than that, we are going to talk about PSD2 compliant login systems. Now, yeah, we know this is a very niche topic, so we are going to try to get into some of the technical details, but also lift our view a bit and have some key takeaways that hopefully everyone can take with them, even if you're not working with these systems specifically. And now Kenneth will tell you a bit about the agenda.
Yes, so here's the agenda we have for you today. First, we're going to talk a little bit in general about API authentication and what alternatives you have when you are securing your APIs. We will also go a little deeper into some of the interesting legislation that Nora talked about. Before we dive into zero knowledge proof algorithms and how that is applied in the Vipps login system. After that, we're going to go through the different security elements that are in place when the Vipps app makes a request to the backend services. And also, we will go a little bit into what happens on the client side. What kind of threats are there on the client side, and how can you mitigate it from the backend? Lastly, we will be speaking a bit about availability and how to stay up in periods of very high load. Right.
All right, so first of all, is anyone here from abroad and maybe doesn't know what Vipps is? Oh yes, okay, all right. So to explain it quickly, Vipps is known in Norway as a payment system mostly. So it is a way to easily send money to your friends and family, and also you can pay with Vipps online. And Vipps does a lot of other things, but these are kind of the main areas that people usually think about. And it's kind of fun to work at Vipps in Norway because many people know about this. So you often get some kind of questions about the different types of things. So for example, sometimes we get asked, how do I add a pay with Vipps button on my website? One time someone asked me, how can they remove someone from a group settlement where you share expenses? Because we were at a party and he had accidentally put his real estate agent in a group for the party expenses. And apparently it was not possible to remove people from the group. Yeah, I didn't know anything about this particular feature, but yeah. And I think one of the most fun questions to get is that sometimes people ask, oh, but why do you even work at Vipps? Because isn't the app already finished? What else could there possibly be to do there? And I think for those people, it can be extra shocking to hear that what Kenneth and I work with, it is basically this. Yes. Looks very impressive here. 3 dots on a screen. And just to say it also, Kenneth and I, we don't even make these 3 dots. We are not front-end developers. This is the app and front-end developers that do. So people can wonder oh, but what do you actually do? Do you need so many people to work on this? Yes, what you see here, this is the login system to the Vipps app. So for those who don't know, what you do is that you can scan your fingerprint or Face ID or write a 4-digit PIN. And then you will see 3 dots on the screen, and you will get logged in. And what Kenneth and I work on is the login system that works in the background here, so behind these 3 dots. And yes, this might still seem very simple, do you need a whole team working on this? And just a disclaimer, we work on a few other things too, but yeah. But yes, to create this login system, you actually have to be able to answer some quite big philosophical questions. So you have to be able to answer if it is possible to have a conversation, if someone is always listening, a secret conversation. You also have to be able to answer, is it possible to share that you know a secret without revealing any information about the secret at all? So without saying anything about what it is or why it is true. And the last philosophical question of all, how to become PSD2 compliant. Yes. And for us, the answer to these questions was our login system, Vinx. And the name Vinx, it comes from combining the word Sphinx, sorry, yes, combining the word Sphinx with a V for Vipps. And this is because in Egyptian mythology, the Sphinx is the protector of the pyramids, just in the same way as our login system is the protector of all other Vipps APIs. So we thought the Sphinx would be a nice mascot to use, to use for the system. And Vinx, it needs to live up to some quite high requirements because we actually have 1.2 billion authentications per year. If we got billion and million, yeah, it is 1.2 billion authentications per year. So the system needs to be able to scale quite well. It needs to handle a lot of traffic. And again, to reach any other API in Vipps, so to do anything else in Vipps, you need to go through Vinx first. And this means that the system, it needs to be quite quick. So here it was not an alternative to make a really slow login system that's very secure. It needs to be fast because otherwise users, they would just drop off. So we needed to find some way to combine the security and speed of the system. And also Vinx has to scale quite well. And we will explain this in the end of the presentation, but sometimes we basically get almost like a DDoS attack on Vinx. So the system needs to be quick and scale well. Yes, and before I go into more, or we go into more about how Vinx works, we are just going to take a quick detour and talk about API authentication in general. Now, this might be well known for many of you, but we just want to be on the same page before we start with the rest. So, if you have some API that doesn't have any authentication at all, then you will have some URL, and anyone in the world can go to this URL and get the information that's served behind it. So APIs with no authentication are just a URL where anyone can ask, okay, give me some data for this user, and they will get the data back. And you can secure APIs or add authentication on different levels. So the easiest level is to maybe add a username and password. So you could tell people, okay, you can go to this URL, but you also need to provide a username and password to get the data back. And as many of you probably know, there are some security issues with this. So if you only use username and passwords, they can be brute force, they can be phished. There are many things that can go wrong here. So another way to secure an API is that you could ask users that, okay, you need to provide an API key to get access to data from this URL. And an API key, it looks a bit different than usernames and passwords. It can look a bit like gibberish with letters and numbers. So it might look like it is more secure, but actually API keys, they have many of the same security problems as usernames and passwords because they can also be brute forced, phished, they can be stolen in many different ways. So what many APIs do is that they require something called an access token to get data from the API. And an access token can look a bit like an API key. There are also some letters and numbers, and you usually send it in a request header called the authorization header. And when you send this token, you get data back from the API. And tokens, they can also be stolen and they can get lost in various ways. However, if an access token gets stolen, it is a little bit less of a crisis than if someone manages to steal a username and password. And this is because access tokens, they always have an expiration time. So here you see an access token to the left. It is encoded with base 64 and decoded here on the right side. And base 64 encoding, it is not encryption or anything like that. So anyone who gets this token, they can decode it and see the information on the right side. And you can see here in the decoded expiration that we have added an expiry time of 10 minutes to this token. So the APIs will check, is this token older than 10 minutes? And they will not accept it if it is. But I just said that anyone, if they get the token, can decode it and get this value to the right. So what stops someone from just changing the time here? So for saying that, okay, this token is now valid for 10 hours. And this is not possible to do because tokens, it's important to remember, they are cryptographically signed, which means that you can always trust this information inside of them as long as you check the signature. So, for example, our login system Vinx, it also signs tokens with Vinx private key, and then anyone can check that that token actually comes from the Vinx system, and they can trust that this information here is correct. And it's also important to remember when we go on with the presentation that these values here, they are called claims. We will get back to that later. And yes, Kenneth, so, okay, we have now said our login system, it also gives these tokens that you can use to access other APIs. But this is not something new. There are many, many login systems that do this, like login with Facebook, login with Twitter. So can you say a bit more about why don't we just have login with Facebook to log into the Vipps app?
Yes, I can say a little bit about that, but first I need to take this little detour into the topic that I know you have been waiting for, to learn a little bit more about EU directives, and namely the PSD2 directive. This is the Payment Services Directive and its second iteration. And it was enacted in Norwegian legislation in 2019. And this sets some central requirements for everybody who do payment processing, like we do. Those are strong customer authentication. We must really be sure that we know who the customer is, who is actually performing this transaction. And it sets some specific requirements on how we must verify this. One of the most important is that we must always use multi-factor authentication. So a PIN code or biometrics together with some possession elements like knowing that you have the phone or something like that. And also, we must be able to provide a mechanism called dynamic linking. And that is that not only must we make sure that the customer, the user is who we think it is, but we also must be able to prove that this user approved this particular payment transaction. And this user approved this particular payment transaction. And this dynamic link kind of creates a binding between this approval that the user does when it gets up the payment confirmation screen and the actual processing of the payment afterwards. So we can be able to maintain this chain of evidence throughout. Okay, but back to your question. Why couldn't we have this in the Vipps app? Wouldn't that be nice? Well, we could, but there are some problems. One of the problems is that all of these are third parties and they don't provide the kind of guarantees that we need to prove the identity of the user. They also don't provide these guarantees that we are required to be able to do according to the PSD2 legislation. So they don't provide this dynamic linking and they don't provide a good enough guarantee that they know who the customer are, at least not in a way that we as a third party can use. And that's only part of the problem. The other part is that doing login is just one, that's just the first step, right? After that, the app will make further requests to the backend and a lot of other things will go on, and we must make sure that it is still the same party that is talking to us. There has not been a man in the middle. Somebody hasn't taken over the conversation midways. So there's a lot of other mechanisms that we add to make sure that we have control over the situation. So that is why you won't see sign in with the GitHub button in the Vipps app soon. Okay, zero knowledge proofs. Sounds like a quite academic topic, but you're going to explain it in a nice and easy way?
Yes. So far, we have established that we have this login system Vinx, and that if a user manages to prove their identity, they will get some access tokens from Vinx. And the question is now, what happens in between here? So how does a user in our login system manage to prove that they are who they actually say they are? And what we use in Vinx is something called the SRP algorithm, and it is based on a concept which is called zero knowledge proof. And zero knowledge proof, that is a way to prove that you know some secret without revealing any information about the secret at all. So if you remember, this was one of the philosophical questions that we asked in the beginning. And Kenneth will go more into details about how this works, but I will try to explain it on more of a high level with an analogy. So the way you can think of zero knowledge proof is that you can imagine this. So imagine that you have a colorblind friend and you have a red and green ball. So is there some way to prove to your friend that these two balls are actually different without him being able to see the colors or see the secret? And here is how the proof system works. So what you could do is that your friend could put the balls behind his back, and then he could place one of them forward, and then put it behind his back again, and place it another one or the same one forward again. And each time he will ask you, have I switched out the balls this time? And if you manage to say to him, yes, you have switched it out, or you haven't, you manage to say it correctly one time, your friend might become a little bit convinced, but he might also think that, oh, you just got lucky and you guessed correct because there was a 50% chance of guessing correctly. But if you repeat this experiment many, many, many times, the chance of you just guessing, it statistically goes a lot down. So in the end, your friend, by just knowing if he switched the balls or not, would hopefully become convinced that, okay, you are actually able to see the difference between them without being able to see the colors himself. This is basically how the concept works. And if you want to learn more about zero knowledge proof, there is a nice YouTube video that explains it in many different difficulty levels, from like beginner to advanced. And we have also linked here the Wikipedia article for the algorithm SRP, because in the Wikipedia article, there's a really good overview of all the implementations of SRP. So if you want to use it in your own projects, you can use some of these third parties in different programming languages and implement an integration yourself. And yes, so this was more of a high-level concept of how our login algorithm works, but Kenneth will now try to explain in more technical details what actually happens.
First, before we get into to SRP and how we apply that, I just wanted to briefly mention the first step that we do whenever a new device, a new phone, tries to speak to the Vipps backends. Because I said that earlier, that we must be able to maintain that it's still the same device talking to us through all the API calls that the phone makes. And the first API call the app makes is it transmits a key, a public key. It has generated a keypad locally on the crypto processor that is present in all modern phones. And the private part is stored inside the crypto processor and can't be extracted from there. And the public key is sent to Vinx. And all requests that the app make afterwards is signed by this public key. So therefore we know that, well, signed by the private key. So therefore we know that the whoever sends this request has access to this private key, and this private key is locked inside the crypto processor inside the phone. All right, so this is just the first step, but then we get into the SRP part. The first thing you need to do before you can log in with your PIN code, of course, is to set the PIN code. So that you are allowed to do during the onboarding process when you set it up. What we do then is we calculate something called a verifier from the PIN code, and also some additional data that we pass along, so you don't have to worry about brute forcing a 4-digit PIN code. And then we send it as a verifier to the Vinx APIs. This is a step in this SRP algorithm. and later when you want to log in. Basically, the process is that both on the app side and on the server side, a calculation is done. We start with random values each time, and on the app we use the PIN code that the user types in. On the server, you use this verifier, and the calculations are a bit different on each side, but the end result is supposed to be that you end up with the same secret key. This key will be different from each time you log in because you start with random values, but it's supposed to be the same value on both the app side and the backend side. And if you manage to do this correctly, that means you typed your PIN code correctly, you end up with the same value, and then you have a shared secret between the parties that you also can use, and that has never been transmitted over the internet. Yes. After a successful login, Vinx emits or issues tokens, just as many other systems do. You get an access token, which is short-lived, and you get a refresh token that you use the next time you start up your app after doing something else for a while. The refresh token is only used with Vinx itself, but the access token is passed to all the other Vipps APIs, and they check that it's the correct access token that is sent, and that it's not expired, and so on. Yes. And then I told you earlier about this dynamic linking requirement that we have, that we need to make sure that the user has actually confirmed the payment transaction. We do that via what is basically a regular login, but when you use your fingerprint or Face ID or PIN code to confirm the payment on the payment screen, when the app logs in, then it passes some key data from the payment along with the login request to Vinx. And if the login is successful, then that data is embedded into the access token. And then later, when the payment confirmation API call is actually made, we have the data in the access token for the payment, and it's supposed to match the actual payment being performed. So that means that you can't use one payment confirmation for one payment to confirm or have another payment process. You can't edit the amount or the recipient or anything like that. Yes, this was a high-level overview. Now I'm going a bit more into the details about the different security elements that we have in a request to the Vipps backend. So we have talked a bit about the access token and the refresh token that is issued by Vinx. I also briefly mentioned that we sign each request with this private key that is created when the app first contacts the Vipps backend. In addition, I've spoken about this key that is calculated when you log in, that is supposed to be the same on the app and the backend side. And these are all present in a request to the backend, and are used to prove different things. So we have the request signature that is locked, that is locking the request, so that you can modify the request and you reuse it on a different signature. The access token also contains a reference to the key that is stored in the app. You have this MFA signature, and it's used to prove that whoever can make this signature correctly was present or was the one that actually did the login sequence. And all of these elements are linked together, so you can't take one out and reuse it on another device or in another situation. So for instance, you can't take the access token from one request and use it to make the same request on a different phone, because there will be a mismatch. And you can't do two different requests on the same phone, but change the details. That won't work either. So this is how a typical payment confirmation request could look. And we have this access token here in the authorization header. It contains, in the just subject claim, it contains this key identifier that I talked about, this identifier of the key that is just stored in the crypto processor on the phone. And it can also contain the payment details if this is a payment confirmation. And then we have the request signature, and that is basically a sign over all the key data on the request. You have the URL and the method, the post method here, and hash of the request body itself. And it also references then this private key that you have on the phone. And you have the hash here as well, that the server that will then verify. And you have this MFA signature that is connected to the shared secret that you that is calculated during the login. And it is linked to the access token, so you can't take that and reuse it with a different access token either. Yes, so this was just a quick tour to how it actually looks when you make a request to the Vipps backend, and how all these elements are linked together. Now I'm going to go into a different topic. When I first started working at Vipps, I was thinking, okay, I'm a backend developer. My job is to make secure APIs, and if the API is secure and there's no known holes in it, then my job is done, right? I don't need to care about what happens on the client side and whether the client has a compromise, because that's the user's concern, right? Whether the user has a hacked app or whatever, I don't care too much about that. I just don't trust the client side, and then I'm fine. But when you work with this kind of like high-value systems that are very attractive to criminals, and where you have a large user base that is not educated in computer security, like we do with Vipps, that is not good enough. We must actually care about what happens on the client side. We must actually help users so they are not victim of different kinds of fraud that can result from having a compromised phone, for example. And there are different kinds of threats on the client side, of course. The most common is low tech. It's social engineering, it's phishing. But it's also possible to hack the app, of course, and modify it. You can have malware installed on the phone that presents overlays that looks like Vipps screens, for instance, or do key logging or other kinds of logging. And you could have a jailbroken phone or a rooted phone, and it can have operating system modifications that can steal your data. From like when you're on the back end trying to defend against all of these, it becomes kind of a cat and mouse game. It's not as black and white as for API security, where you either are secure as far as you know, or you have a hole and must fix it. In this case, it's a constant balancing of how many fraudulent transactions you catch versus how many false positives you get. So we don't want to annoy the users either. And I'm not going to go into in detail what kind of rules and checks we implement here, because that can change. But there's one mechanism I would want to go into, and that is that we use remote attestations. That is a feature that is present in both Android phones and iOS phones, and where you basically ask the phone to present to give you an attestation that verifies that the environment that it's running on, the operating system and the app itself hasn't been modified. So the app will basically make a request to Google or Apple, and that request will then be sent to the Vinx APIs, and we will validate that it really came from Google or Apple, and that the attributes, the information inside, says that this device and app can be trusted. And if this check fails, then the device is blocked from speaking with the Vipps APIs. Yes. And then the last topic, availability and how to stay available.
Yes. So at Vipps, we have some very high traffic days where we suddenly get a lot more requests than usual. So for example, for those who are from Norway, you might know about 17th of May, the Constitution Day, where everyone is trying to buy stuff at different kiosks and paying with Vipps, because we almost don't use cash anymore at all. Then we also have Christmas Eve, because we have a gift function, so many people send gifts via Vipps. And we also have something called TV-aksjonen, and that is a big charity event in Norway, where the state channel, they create a big event with a lot of things happening, where people are supposed to send as much money to charity as possible. And during that time, we have extremely high traffic via Vipps, because that is one of the ways to donate. And we will talk about how we ensure availability. And one of the things is to make sure that our infrastructure scales. But we also need to make sure that our system works quite fast at every time. So what we try to be careful about is that every time a request happens, there is not more than one read and write to the database. So that is a good rule to remember if you're also making other systems. And then we also try to have asynchronous calls for various things. So for example, if we are going to block a user, we don't stop the entire login sequence to wait to see if a user is blocked, even though they will not be able to log in, but this will be an asynchronous job happening. It will not be one step that just simply waits for another at all times. And then we try to have as scalable infrastructure as possible. And what we use for Vinx is that we are on Azure. So we use Azure Functions and Cosmos database, which is a NoSQL database. And Azure Functions is basically a serverless option. So it means that you don't have to manage your own machines, and it's supposed to scale automatically. However, before TV-aksjonen and some of these events, we still have to make sure that we have enough standby instances in the background to be able to scale quickly enough for the first wave. And with Cosmos, we are also able to scale it inside of Azure. And we have had experience with this working quite well for the recent years for TV-aksjonen when we get a lot of requests. Yes. So in the end, we just want to say some quick key takeaways. So when I first started working at Vipps, I thought it was kind of cool to see the Vinx system and the SRP algorithm, because to me, this was being able to see that, it's possible to make a system that is secure, but that also is really quick and hassle-free for users. And I think in recent years, we have actually seen more of these systems, which are both secure and easier to use. For example, with FIDO2, if anyone is familiar with that, that is a quicker passwordless way to log in. It's quicker and both more secure. And also what I saw here is that when you have really high security requirements, I think it can actually drive innovation in a way. And this is because if you are going to make a system, and you have no limitations. So imagine that you have just all the manual resources you want, you have no security requirements, then I think this will actually lead to a more inefficient system. So for example, once I used like a train app system where you buy train apps, and this was in a country where they had access to a lot of manual resources. So someone was manually approving each like transaction in the background because they were able to do this. But if you don't have all of these resources available, then you need to think more about automation and doing things quicker. So I know I hear from some people that maybe all these requirements, that we have all these regulations and security requirements in the Norway and in the EU, it will just slow us down, we will fall behind. But I think actually quite the opposite will happen, because I believe these limitations will lead to more high-tech solutions, because there is simply no other way to get this done. Yes, this was everything from us. Thank you so much.